Okay, we're live. And Tara is here as usual.
Hello, everyone.
And we're almost to the end.
Well, I don't know if I should cheer or not.
I think it's worth cheering. Also, it's almost the 20th, and I have to submit to that thing on the 23rd. So that snuck up on me.
You've been thinking about it, though, I assume.
Yeah, I guess it's just a proposal, so it's not like finishing a talk or something, but this is the GopherCon Europe. But anyway, let's do some Wanix stuff.
Do it.
So we're almost done. I did finish the 9p bridge from Linux to Wanix, and that's pretty exciting. I'll show that. I also proved out one of the last sort of weird, difficult things that I was unsure if it would work. So now the hard stuff is done. We just have to do some work. Which mostly has to do with running processes, which we haven't really. We have this proc file system, but we mostly use it as a way to manage namespaces. We don't actually use it to run anything yet, and we want to run WASM binaries, and we did get WASM binaries running in the browser and sort of wired up to the Wanix file system. But now we need to wrap that up into the proc file system API to make them, which and then also kind of finishing up the interface to processes once they're running. So very similar to like the slash proc is a thing in Linux. It's one of the few things that is really sort of directly taken from Plan 9 that's in Linux. I guess there's a bunch of other stuff too, but that's the most obvious. But in this version of proc, the way you would even run a process. Normally, when you run a process, you do it from the command line. You're like, I'm gonna run foo. But we have to do a whole bunch of other steps just to set up foo, which we can then abstract and hide away. But basically, you'd start a process by doing like proc new WASI, and that would give you an ID, and then you'd have proc 1, and then something that looks like this. With a control node where you could start the process, kill the process, send signals to it, anything else that you can't really do through these other things. See what the command line arguments were, the environment, current working directory, what namespace does it have. it's file descriptors. So this is all standard IO stuff, and this is interesting plumbing that we have to set up, because we have to kind of wire these streams up and then exit. So when a process finishes, it has an exit code. And so that's kind of the same API as anything that lets you run like a sub process. And that's kind of, so it's the same API here. So you would sort of allocate the process, and then you'd have to basically set all of these things. Set, if you have environment, you'd write to environment. I mean, even the command line that you're running, you'd have to write to this file. And then once it's all set up, then you would send a signal to start. And then whatever is attached to these file descriptors the process will read the input as standard in, and then its standard out and standard error would come out over these file descriptors. And so what's actually listening to those, what's actually using those, in our Linux VM, the idea is we'd create a command called wexec. And so you would run wexec with the program that you would run, and it would do all of this stuff, and it would set up the process, and then basically attach its standard in to this file descriptor pipe, and read these output and just output it as this process. So it's sort of like a proxy process in Linux that then attaches to the Wanix process. And this is because we're using Linux as our shell, but Linux, but we want to actually run processes in Wanix and have Wanix sort of manage them. So then this LD preload thing is an interesting Linux hack where if you create a shared library, you can compile code to be used as a library. It's like SO files, shared object files. Before you run a program, if you specify in the environment LD preload and then specify some library that you've compiled, that will be linked in to the program at runtime. And you can intercept pretty much all of the system calls that are made. So you can kind of, take over or hack the process that you're running. And normally when the way to run a process, like the way any shell would run a process, is it would call the, there's a bunch of exec functions in libc. And so we can intercept those with LD preload. And then set up our Linux shell so that when it starts, it uses LD preload with a custom little interceptor. And then in Linux, we wouldn't have to write wexec foo. We could just run foo as if it were a Linux process. But then before Linux even gets a chance to try and run it, we've intercepted it and basically have said, is this a WASM file? If yes, then we'll run wexec foo, and then that will kind of allocate this Wanix process and wire everything up, and then start the process. And then
go
ahead.
Sorry, go ahead. Well, I was just from my understanding, so it means the end user can just use Linux commands and not have to think about the custom like Wanix commands.
Yeah. The idea is you're in a kind of a Linux environment, a Linux shell, and we want to be able to run WASI binaries, and so this lets you run them no differently than you would run a regular Linux executable.
Gotcha.
But again, because the Linux shell is running in a VM, that's sort of like not the real or intended. The whole point of the shell is just to be a shell to Wanix. It just happens to be a Linux environment, which means we can run x86 Linux binaries. But that's a compatibility goal because we want to be able to run WASM stuff, not just because Wanix is a WebAssembly operating system or whatever, but you can't run everything in the VM because it's going to run slower. So it really is kind of intended for compatibility. And so if you want the most performance, you would want to run WebAssembly stuff, quote unquote, natively outside of a VM, even though WebAssembly is a VM, but basically not a VM inside a VM. So yeah, this lets us run WebAssembly binaries from Linux without doing anything special. Yeah, I think that's pretty much it. And then we have a way to run WebAssembly binaries or executables, and one of the capabilities too that I think I want to work out before this release is how can a process then expose a file system to Wanix, and that way anything that provides a file system can just be a WASM executable. It becomes the a way to package up, these file systems or whatever. It's sort of like if you think about an operating system, an executable is almost like a plugin, right? It's like, here's a thing that extends the capability of your operating system. And so in that same way, we can use these WASI executables to, either run like a normal Unix utility or whatever, but also kind of run as a server that provides a file system to Wanix. And that's very similar to Plan 9's architecture, where you'd run a process and it exports a file system, and then you can put that. So it's a way to get new types of file systems in Wanix, as well as being a way to run processes. But anyway, also because it's WASI, I'm hoping to try and get the Go compiler to compile to WASI. The old version of Wanix, Julian wrote a sort of a specialized stripped down Go compiler that worked in that environment. And part of it was because the full Go compiler didn't work, wouldn't compile to it. But I think we can get the Go compiler to compile to WASI. And so then if we can, then we And if we can run WASI programs, then we would then be able to run the Go compiler. And then we're back to where we were with the old Wanix, where we have an environment, a Unix-like environment that we can create programs in. And in theory, we could run the Go compiler in Linux and v86, but it would be incredibly slow. Not that slow, but for a compiler, we want it to run kind of as fast as possible. And we can do some experiments to see, once it works in WASI, how it compares. But that would basically prove, like, okay, now we have this Unix-like environment. We can run WASI processes. That's something that the old Wanix couldn't do. We can run the full Go compiler. That's something old Wanix couldn't do. That also means that in theory, if we had, the source code for Wanix in this environment, we'd be able to build it. So then we come back to the story of being able to build Wanix from within Wanix. And then this becomes an easy way to build new 9P servers or file systems. And so then it becomes a way to sort of like play around with the file system stuff that Wanix gives you. So then that's sort of like, to me, enough. And then VS Code, I guess, is the last thing. And the idea is to try and package up, I guess, VS Code as a WASI binary. And part of what it would need to do is, as some static files. The VS Code for web is just static files. So this binary can then maybe mount them to the file system so that our service worker can then serve them, and then we can open an iframe pointing to the path where VS Code static files are, and we'd have VS Code in this environment. And then with VS Code and the compiler, then we'd have a full self-hosted environment where we could build Wanix within Wanix, but also lots of other things, and then da-da-da-da. But at that point, it's sort of like functionally, finally good enough for a release. So we're really close.
All right.
Even though that sounded like a lot. Let me show the 9P stuff really quick, though, because I already kind of cleaned it up. Let me do this with debug on. But basically, we had set up this 9P server and set up some plumbing to kind of hook into the virt.io driver or whatever in v86. V86 has a virt.io 9P device, which lets you mount 9P file systems in v86 without networking, because it's a virt.io device. It's as if the machine has like a specialized PCI card or something. But it turned out that this basically just sends and receives 9P packets, and so we created this hook that lets us, whenever there's a 9P packet, we send it to this virt.io handler, and then we also pass it a function that handler can then write a response. And so that's pure 9P protocol stuff. So then we have our 9P Go implementation. And so the definition of this handler is defined here. where we're basically taking in those bytes and writing them into a pipe that feeds into our 9p server. And then it writes 9p responses out of this pipe. And then we use the callback that we passed in here. So this all works now, and what that gives us is kind of a much simpler way. This /Wanix is a 9p mount of the Wanix file system in this Linux environment. What was I going to do? I was going to enable debugging.
It's looking legit now. I don't think you actually had the shell the last time we...
Yeah, this was kind of a bit of a turning point, because kind of the whole point is like, oh, because Wanix is the file system, you can interact with it with a shell, but we've had a really limited version of that, and this basically gives us a... Okay, so here's all the 9p packets from the v86 virtual machine, the Linux environment, being sent out and being received through the little plumbing that we set up into the Wanix WASM running a 9p server that is serving this directory. And we kind of had this working before where you could, at least read stuff. Although it took forever to get it to work right. So this is OPFS, so these are files that are sort of persistent. So here's a little worker JavaScript file, which we have our web worker interface, so we can create a web worker. So now one cat state, so it's allocated, it's not running. We can echo start, and I made it so that you could pass a path, a HTTP path, for it to fetch the worker JavaScript that it would use for this web worker. And we have our service worker stuff, so we could access that worker.js by going to the path service worker, which is right now where we're handling all service worker requests. And then the service worker is basically just handing the path off to the file system. So from here, it's the Wanix root. We can say OPFS and then worker.js. So worker.js is a file in OPFS that is part of the Wanix file system. And then the service worker is making that accessible over HTTP on this domain. And so that lets us set up a new service worker, which, you could do via JavaScript, or you could do via this file system interface. So we send start to control. And so now we're getting little hellos down here because our worker script was set interval console hello, console log hello every 2 seconds. So that's going on down there, if you can see it. We can also terminate. And it's stopped. So all of this stuff, all of these file system operations are happening over 9p. So we're seeing all of these packets as we're doing stuff here. But we could also, finally can do body background color red. So that's pretty cool.
Oh, nice.
What else? Basically, the thing that we couldn't do was any write operations. So all of these things where we're writing into control files and writing into style and being able to make files under OPFS or whatever, we weren't able to do that in this shell before, but now we can. So now this is closer to the vision of how you'd be using Wanix. So the 9p stuff is super cool, and I'm glad that that's finally there. But we needed to get that to work before we could do the process stuff.
Mm-hmm.
Where are my notes? So we can run workers, web worker, and that's basically what our WASI processes will be. It's a web worker that will run kind of a built-in WASI worker that we already put together, that then runs its own worker to run the synchronous WASI code that has to be in its own worker because it's synchronous. And then that would let us run WASI binaries, and we want to do it through the file system interface. So I've been kind of working on finishing that, making sure that you can set the command line, the environment, the directory of a process through the file system. I mean, right now you can this is sort of our empty root process that provides the namespace that we're using here. If you remember that, if we go into namespace, we just see, it actually worked. I was worried it was going to go into recursion. But the file system that we see at /Wanix is this file system. So it's sort of recursive. Anyway, the whole point of this process is it's not actually running anything. It's just we're using it for its namespace. But we can still see that we have these basically fields. So command will hold the command line. So if I wanted to run some program with some args, basically that is what we want to see in command. What was the command line to start the process? And that's where we figure out where the WASI executable is that we would want to run. But anyway, so we should be able to set these like foo args arg. I think we can just do this. Yeah, so they're almost like fields that we can read and write. These are the easy parts. The hard part are the file descriptor stuff, all the standard I/O, streaming, input and output stuff. So we're gonna do that. And we'll see how far we can get on these last couple of things.
All right.
I'm gonna turn this debug stuff off. Let's see. What am I doing again? Working on the file descriptor stuff. So, oh God, I don't know. Maybe, yes. So we've got these fields. Do we have exit? I guess we don't have exit. I guess we'll store it as an integer, but although that would mean we'd have to convert it. I'll do it as a string for now. And then we create the field file for it. So we made this field file thing a long time ago. Let's us just make a file that will output this string. And if we write to it, then we can do whatever with that data. So we can set it to trim it and then set exit from the setter bytes. Okay, but now we have to make a directory called file descriptor, or FD, with all the standard I/O stuff. And the way this is gonna work, this is sort of like a, how would I, like it functions as a configurable pipe. Like depending on what kind of process this is, what these are wired up to might be different. For WASI, let's see, is that true? So I guess for in WASI, let's see, you're in a web worker, you have access to the file system, so it could basically read these files for itself, like figure out which process is that it is, because you can always look at self. And then go in and attach and basically open FD0, and what would that look like? Read from it and then pipe that into the standard in for the WASI process. And then we would read standard out for the WASI process, and we would write to these, and then anybody else that reads these will get those right. So it's almost like a little broadcast point is kind of like what we're making with these. And it's probably going to be implemented with a pipe where the first person that opens it gets one end of the pipe, and then after that, anybody else that opens it will get the other end of the pipe. So it's kind of set up so that when the process is set up to run, it'll be the first one to open it, and it'll be the one on one end of the pipe. And then anybody else that opens these will be on the other end of the pipe, and so that's then how you're able to communicate between them. It's mostly through a pipe, but sort of located at these paths, which is kind of a cool model. I don't know. Anyway,
yeah.
Let's see. We have to make a directory. I guess we need to figure out what these are going to look like. They have to be files. We did do a stream for our VM serial. Where was this? Oh. This one doesn't have to be a file. Let's see. We did. What was the other end of this? The terminal, the DOM. When we made that terminal, we did that special case where it has that data line. And so this is kind of what we want to do. We want to implement a file just like this that we can read and write, and we can basically hand those off to a pipe. Data. So we'll want something like this. I think. I'll just throw this down here for now. Let's see, where are these going to be initialized? I guess we can set up the pipes. I guess we can put them on the process as resources, just like the device does for each process. File descriptors. And then that makes it easy to do the FD directory, because it is just what is it? fskit How does this one work? Oh, we convert it to a mapfs. RFDs. All right, so that gives us a directory of something, whatever we put in this map. And so let's see, when a process is allocated, maybe maybe that's where we set up the pipes. Okay, yeah, so I guess we can think of now implementing the individual file descriptor files, which is basically what this will be. So I'll rename it, but these are interesting files because the first open behaves differently than the others. The first open will give you a file that gives you one end of a pipe, and then the future opens will give you the other end of the pipe. I don't know how to set that up yet, but we'll just start renaming some of this to like file descriptor pipe or file FD file. Let's see, buffered pipe. That was for our term data stuff, so we're not going to do that. What will this have? Let me figure out what this would look like. AB net pipe. Oops. So NetPipe gives you what look like TCP connections or sockets, but they're basically pipes. But pipes are usually just one way, like one side is a writer, the other side is a reader.
I was going to ask, I don't really know what the difference is, so
yeah,
that's the difference.
But the connection has both a reader and a writer for both ends, so it's like a full duplex pipe. And since that's basically what a socket is, they just use the socket interface, the net connection. There's some other stuff on net connection, but it's mostly, read, write, close that we care about. But anyway, so this will set up two ends to this in-memory full duplex pipe, and yeah, it's trying to guess how we would set this up. The problem is string to file system. Term data. So we can do something like, what would this be? New FD file. I guess it could create its own pipe. Let's look at but we want to return a file system, so something with open. But how does that work? What do we have down here? New term data. I guess the way this was set up for term data is it returned a file, but we want this to actually return a file system, because that's what goes in a mapfs. But also then we have control. Then we have open, which is where we could be like, is this the first open? Then you get this end of the pipe. If it's any other open, you'll get the other end of the pipe. So I guess we get get rid of all this. So if ultimately we're returning a file system, we can do a Yeah, so this is where we can set up the pipe. Where is... And let's see, FD file will basically just have one end of these. I guess we could just have it wrap a net connection. New FD file. Let's see if this is run once, then it would have closure state. I'm trying to think about the state. How do we track whether this was the first open or not? But I think we can like do something like this, or I hate naming this because we want something ideally that's false, so we don't have to set a value. I don't know why that's why I want to do it, but what would be false on first open? Has opened, I guess. Has opened would be false on the first open. Yeah, okay. So we've got our two ends of the pipe. We would say if has opened, if not has opened, sure. And then we would set it to true. Has opened. So this is the first one. Otherwise, I guess the second one. I don't know if this is a great idea to, like, I've never seen a file system that behaves differently on different opens, but we can do it, and we have...
But why?
Well, I don't know any other way to do it. And it's not something that the user will see because it's a system thing. Like, it's always going to operate the same except the first time. But the first time will be system code that's going to do the open. So from the user's point of view, it's consistent. Does that make sense?
Well, yeah, that seems fine then.
So that's why I'm willing to try kind of a weird thing here.
Yeah.
So okay, that was pretty easy. I guess. We can just create a couple of these. And make sure these are all what they need to be. So read and write, we can just pass that on to connection. I guess, what does it mean to close? Do we want it to close the I'm gonna make close a no op. and just see how that goes. The file data. So the metadata for this file will be 644 will be file permissions, I guess. That makes sense. The name of the file though won't be data, so we need to set that. I guess we can do name and pass that in. Yeah, that's pretty simple. We have to name those. Let's see, how would we test this? Especially because they're streams. Most of our tools are sort of like write this whole file or read this whole file as opposed to like keep reading. Although we could make that. Well, let's see. What's another way we can test this out? I've made such a weird system. I'm like, what do I? There's so many ways we could do this. Let's see. So part of the problem is we need kind of like two things happening at once, because we need one side to sort of like open it and then write to it, and then we need another side to connect to it and then read from it, and it should get the writes from the other end. I guess technically in Linux here we have tail, which is basically open a file and then keep it open and keep reading. We could try that. Actually, yeah. Who? What?
No field or methods.
Did a package get upgraded or something? What? 270. 250. Huh. So Cbor was actually the package that I was waiting for it to work with TinyGo. And it was something like this. So I wonder if they regressed with this new version. Because this is pretty much literally the error that I was getting back when it couldn't compile to TinyGo. maybe, hopefully we can just set this back to 5. I don't know, I've never had to deal with this before. Okay, that did it. I wonder what caused it to upgrade. I don't even know what does that. Unless you explicitly
Yeah, I
do
would
it.
have.
If you did like a go get again, it should upgrade it, but I don't know. But maybe because it's indirect, like it was a dependency on something else. I don't know. That's weird. Anyway, it built, so let's... All right, so we have our root process, so we can go in there to check to see how these work. So let's say we run tail on 0. No, tail dash F, I think is what you want to keep it open, right? Dash F causes tail to not stop when the end of a file is reached. Might not even need it, but okay. So this should kind of just sit there. And then we can try maybe over here doing proc1 follow the scripter 0. Hello there. Okay, it wrote it, but we don't see anything over here. So that's a little bit of a bummer. I don't know if it's because tail doesn't work or if this doesn't work the way I thought it would. So I mean, we could write a test. Ugh. Yeah, let's do that. Let's write a test. That will hopefully tell us why it's not working, or tell us that it is working before we move on to other stuff that uses it. New FD file. Okay. That's interesting. Let's see. Okay, so this should open a file or one end. It's almost like we're using the pipe. So the first open is one side of the pipe. And then another open would be the other side of the pipe. And oh man, what do we want to do? Maybe we'll create a buffer and then copy one of the, let's say B is the output, goes into the buffer. And then we would write into A, And then in theory, we should see what we wrote into A end up in the buffer, because A would go into B, and then B is going into the buffer. I don't know, right string. What's wrong with A? Oh, that's true. Let's try right. What's wrong? That's wrong. And then, yes, you guessed it.
It is noon, by the way.
All right, let's see if this test works. And then decide whether we can take a break happy or sad. I guess, though, actually, because it's a pipe, it's not going to stop. How do I mean that? Like we're going to write into it. And then, but this copy doesn't know when to stop because there's no EOF. It just keeps reading this. And actually this is blocking, so it's not even getting to the right. So what do I want to do here? We're very close. Just hold on a couple minutes.
Sure.
I guess I would do this asynchronously. And I guess maybe we don't need to care that it's not closed. What must be called in the same coroutine as test? Oh, because of T fatal. I guess we'll just print the error if there's an error. Log. So it's going to copy into buffer, and so it won't necessarily be done after this write, but at least buffer should have hello. Expect to hello got nothing. Okay, well, we could take a break here. It's always a sad break.
Oh, that's not true. But I mean, you know, we usually end on a good note.
Yeah. All right, well, let's take a sad break.
All right, 12:10.
Cool.
Okie dokie.
Oh, you're back. Guess what?
What?
I used the break to get it to work.
What the hell, man? Do you know what a break is for?
No, it's a time to think without performing.
Mm.
I stretched. I had a sip of Pepsi Zero.
Ew. Did you choose that over Coke Zero?
Pepsi Zero tastes like Pepsi.
So you prefer Pepsi over Coke?
I don't know. I might be switching up.
You know what's really good?
Tell me.
Dr. Pepper, strawberries and cream. They make a zero
Oh my god.
version.
That
Yeah,
sounds amazing.
yeah, it's really good.
Dr. Pepper what?
Strawberries and cream.
Holy shit.
Yeah.
Is this real?
Yeah, I have it in
Huh.
my pantry right now.
Well, I'll have to come over and have some.
Yeah, I was just thinking we need to hang out sometime soon. We also have 7-Up, like tropical flavored zero sugar.
7-Up Tropical. That also sounds pretty good.
Yeah, it is.
7-Up's already pretty tropical, so
Yeah. Yeah, it's delicious.
So it turns out all we needed to do was sleep a little bit, because we were doing stuff in parallel. We did a write. There wasn't necessarily enough time for that write to go to the other pipe and then get copied to the buffer. So
Sleep fixes all kinds of things.
I know, but it should not.
I know, it does sound terrible. I just wanted to make a joke about sleep.
I'm glad you get that joke.
Thanks you. Thanks so much.
I mean, I can't think of a better way to do this signaling right now, so I think I'm happy with this sleep. Plus, the whole point was to really just prove that this works so that as we build on top of it, we're not like, why isn't this working? But that's cool. I think the first open is one end of the pipe, and then I don't know what happens if you open it a third time, but we'll ignore that for now. And then the second open basically opens the other side of the pipe.
Do you know you still have your like break screen on?
Is that true? Maybe you need to reload the stream.
Well, okay, let me try that. Okay, no, it's your actual screen. Maybe it was my stream is messed up.
Yeah, that's weird. That would have been a pretty long delay. But good to be checking. Hopefully the audio is working too.
Oh yeah, I did check last time, but I'll check this time.
All right, so FD file works. And now what are we doing? Basically, we want to get the WASI-proc stuff done. And so now we have to revisit our WASI worker. Let's see how would this work. Process, maybe it passes in. speed. Tara, do you remember how any of this works? WASI worker.
No, I don't.
I guess we can test this again. Although instead of hard coding the WASM, we can. Okay, where is it going to get that? I guess E data. So we send a message to this, and now that message can include a path, but I don't know where we're going to get it from here. I guess it's hard coded for now again. Where is that program? Copy this. I guess I'll put it in assets for now. No, I'm gonna forget. I don't know. All right. So if it's in assets, then we should be able to just load it. It's a URL path. Okay, so that calls worker sync. So here we just need to create a worker based on WASI worker. So let's try that. I don't know if you remember, I made this example Rust program. Actually, I don't know where the source, I guess in WASI. And what does it do? It reads the root directory, prints out all of the contents of the root directory, and then it tries to read OPFS file. And that's it. But we can use that as a test to try and get it to run some WASI. Let me make sure that it, what was it called? Example RS. All right, so that loads, so it's serving that. And it's a worker script, so you should be able to set up a web worker. Echo start / example RS. Oh, I guess this is not going to matter because it's, oh, no. This is the, it's not the WASM that we want to start. It's the worker script. WASI worker.js. WASI worker.js. Okay. HTTP status code is not okay. It is not okay. I'm guessing maybe that path was not good. Maybe we should make sure that we see what that is. Something has made compiling slower. All right, web worker. Fuzzy worker. Undefined. All right, well, that's why it's not working, because there's no path. Data path. Sync. Oh, I put it in the wrong place.
That'll do it.
I guess this is what I want. Okay. So we're trying to hard code the path to be example RS just to. Man, TinyGo. TinyGo is built on traditional compiler tooling. But one of the whole points of the Go compiler was to be very fast. And unfortunately, TinyGo is not fast, but everything's trade-offs. WASI worker JS. Look at that. Look at that. So that it ran the WASI.
Ooh.
I mean, we had this working on some bit ago, but it's nice to see that it still works. And now we can start integrating it. But so that ran it hard-coded. What we want is WASI worker to somehow be passed what file to run. But we don't have a good way of doing that. Although, so we do a message and pass worker. When we start a web worker, we immediately post to it an event, an object called worker that has, where did we write this? This is, I guess, in worker. Yeah, it posts the ID of the worker, and then it posts a port that has the file system. So then the worker can like interact with the file system. But we could have it post, because there's no like good way to give arguments to a web worker. Maybe the query parameter, but I don't know if I want to do that. Start. So we can make up a way to pass parameters to it, to a worker, web worker. So I don't know, we have to kind of do some design here. I mean, one thing that we could do is kind of make it process like, and if there's other arguments at the end of start, that those are passed in. Though maybe that is... Maybe something like that is the easiest thing. We can pass. Man, that's making it more like a process, but whatever. Command line, strings join the arguments. So what we use to call start, we can pass in as command line. And let's see. Could be worker, command line. Data worker, command line. Split. How do you get the last element in JavaScript? Can't do -1, can you?
I don't remember.
Oh, JavaScript. Nope. Maybe you can do that with slice. Start. Okay. That works. Kind of unintuitive, but
Not too bad.
yeah. We'll just assume the last argument will be what we want to run for now. And so let's rename this to just example, so we can try running example. What do we need to do? I think that's it. We can rebuild and we should be able to do start WASI worker and /example WASM. Once it fucking builds. It's so nice to be using this shell now instead of the JavaScript console.
Pretty exciting.
New. All right, start WASI worker. And it was example.wasm? Yeah.
I think so.
Okay, that started it. Cool. All right. So we're one step closer to the edge I'm about to break. You didn't listen to Linkin Park? What did you listen to back then?
I still listen to Linkin Park.
Oh.
Yeah, I mean, I listen to I guess kind of emo, but not really whiny, super whiny stuff. More like some angsty stuff like Linkin Park.
Yeah, angsty. You're not an angsty person, though.
I mean, as a teenager, I definitely was.
I guess what teenager isn't?
You know, you say that, but Garrett and I talked about, I don't think he really had an angsty phase.
Huh.
Maybe he had, a healthy home life and parents who
Can you
were
imagine
kind to him.
An emo Garrett?
No, I really cannot.
Okay, so
Wait, why'd you ask me about Linkin Park?
I referenced. I said I'm about to break
Oh,
something.
my sister. Sorry,
Go ahead.
my sister just went to go see them with their new singer in Mexico.
Oh, I heard they're good. Like they had I don't know, within the last year, an album, and it sounds like their old stuff. That's kind of impressive.
I haven't checked it out, but I like they've got a woman front lady. It's pretty cool.
Yeah, she kind of has some pretty good energy, so it's like a good refresh for the band.
Yeah, I mean there was some
they're all
controversy.
50 or whatever.
Yeah.
Controversy?
Okay.
What?
With her, I don't remember exactly something she said or did.
That she's a woman.
People.
That upset people.
Probably certain people.
Yeah.
But no, I think like I don't know her beliefs or she said something.
Oh boy.
Shitty. I don't know.
Yeah.
Anyway.
Okay, so we can start a web worker. Oh man, we're gonna have to do a bunch of weird stuff. So we can start WASM directly as a web worker, but now we want to start we want to be able to start this as a proc through the proc interface, and it's just gonna behind the scenes start a web worker, but trying to orient myself in what we're doing next. So proc, I created a process type called WASI. I think I tried to do something crazy. I guess, let's see. New start. So when you start a process, it runs start. So I stubbed this out. If type is not WASI actually, then we'll just return. Okay. Okay. So this is where we would start the web worker based on this process. How do we do that? I guess that's the namespace that the process will get. We need to create a web worker, which means we need access to the file system, which means oh, this is going to couple with web. Oh, maybe not if we use the file system. Let's see, so we create a namespace. What does this do? Creates an empty namespace. Oh, that makes sense. So far it's what we wanted. But we want to Usually when you start a process, you want it to inherit the namespace of the process that ran it, and we don't do that right now. Shit. We can get... Or we could just pass the kernel in here. That would be a little easier. Kind of like we did for web. I don't love this, but it's definitely easier. Although, does kernel depend on proc? We might not be able to do this because of a created dependence, circular dependency. So I can't actually. Shit. Crap. Proc needs a reference to something like namespace, which we put on K on the kernel struct, but it won't be set here, so we can't just pass it there. We can't pass the kernel because then we'd have to import it and it'd be a circular dependency thing. Proc device. Oh, maybe we could have it so web sets it up. Hold on. Let's see. What are we trying to do? We want to call... We're going to call the web worker stuff. We could even... just make this API something that it could use and then pass it in. Let's try something like that. So let's see, we want to do an allocation, kind of like proc. We pull everything out. Alloc name. Oh, it's the kind. Oh, okay, that makes sense. Okay. There's kind of a web worker, and I'm pretty sure, I guess we could return a resource. And so this becomes this. RID, next ID, create a new thing, do Okay, so that will allocate it. R. Maybe we'll do ID. I think that's what proc did. Why are these files so far apart from each other? Let's see. Process ID. Okay, so we did do that. So that will convert our ID to a string. So we can use it there. So now alloc is its own API that we can call. And then we want to call start on it, I guess. So maybe instead of doing this in here, we would figure out how we would. Ugh, this is hard to look at code.
Yeah.
So this is argument parsing. So that's URL message channel. Port responder. Post message. Okay, I think we want this stuff. Start. URL. Let's see. Yes. I think this is what I want. Oh, but it has to be a JS value. That's going to be weird. Or of source. Oh, okay, we could read of source. Shit. Maybe we can do something. If now we've got multiple things called URL. What is this? Worker path. It's kind of weird because worker path is sort of optional. And if it's not set, it's going to read from source. I guess, let's see, if worker path is not empty, then do that, and then that gives us URL. That makes this work. Oh, but we lost args. We were using that. I don't know. I guess I'll add args. Optional args. Actually, why not just make them all args since worker path is optional? And then if length of args is greater or equal to 1, and then that works. See, there isn't even an opportunity for an error to happen. So I don't even know why. It just won't do anything. Maybe we should think about it in the future. It could return an error. I don't know. But anyway, so then we can do our start. Yes. Okay, so now it has an API that we can use from Go, and in theory we can pass the worker device to the proc. As like a, I don't know, as like a, this is making it web specific, but I guess we will pull this out later. Oh no. Hopefully this won't create a circular dependency.
You mean you don't know ahead of time?
Yeah, I just forget what imports what. Let's see. So the idea is if we can get proc, if we have the kernel, we can get proc and we can set worker. So let's see if we can do that from web when we set this up. Here's the worker module or whatever. I guess maybe we should call it worker FS. And then we can do K proc worker equals worker FS. Is that right? Proc worker undefined. What? What? Kernel K. Show me. Proc. What's the problem here? Using metadata for import of.
You don't hear Lotus, do you? She just meowed like right into my microphone.
No. I mean, I heard some purring just now, but.
Oh, yeah.
What the hell? Something is wrong. Could not import. Proc. Could not import. That's not true. I mean, it's mostly because we need this type, but we could make this an interface. Well, that'd be a lot of work. Shit.
What?
How do we get a reference to the worker device? We're almost out of time. It's always something stupid right near the end. And so then like the cool it works moment happens off stream.
I mean, to be fair, you don't have to work on it off stream. You could work on your GopherCon proposal.
That's true. But I want to get it done. It's taking too long. All right, I'm a little lost. I think if I take this out, everything's fine again. But so let's see. We're gonna need to like do allocation and let's see. Proc. I mean, maybe those errors are just because it doesn't know what build mode is going to be used. Damn it. It's not even like an interesting programming problem. It's like just like how to organize stuff to access without causing some weirdness.
Is it something like you need to think about the bigger picture more?
I just have to brute force figuring out what works.
So the opposite.
Yeah. This is what gets me, and then I'm just like obsessed until it's working.
Yeah, I know the feeling. Just want to check it off.
Yeah. I'd love to check off Wanix. That would be great. Just a whole thing. Let's see. So the process needs to allocate and start a worker process or a web worker. How? Use the API directly, but it's for WASM. Let's see. We do have this whole type registration system where we're not actually like using this factory function. Maybe we could use that as a way. How does this work? I don't think factory is actually used or called. But I guess we could call it. When we allocate a process, no, we need to hook into the start of a process. Maybe the factory returns. Maybe this is the start. Maybe all this is something that starts the process. We can do that for now, and then if we need to change it later, we can. It's not really being used for anything at the moment. What is the problem? Oh, register. factory, it's more, we'll call it like a starter. And then we can put starter. And then starter for that kind. Cool, like cool spam. That's weird spam.
Oh yeah, special interest crocodile. Let me get him out of here.
Okay, here we go. If starter is not nil, call our starter. Wait, oh, starter does take a process, okay. Start, so when you start a process, depending on the type, it will do a different thing. And then so now we can potentially do this from another, from like web. Yes, yes. And so now here we can set up the do the worker stuff. So let's see, worker FS. So this will create a worker, and then we want to start it passing. For now, it's the WASI worker .js. As that argument, and then the actual WASM to run, we would get from the process. From the command. Yeah, we'll do args string split. Actually, yeah, we can just pass the arguments of the process to the arguments of the worker. It doesn't like that because crap. Args. This is stupid. I know what time it is, but man, we are very close. This could work. And maybe we'll get that validating feeling before we end. All right, so this registers process type. It's going to create a worker when it's started based on the command. All right, so now we should be, I think we have everything to start a process that will start a WASI web worker. Okay. So proc. Let's see that new has WASI is registered. Cat new WASI. CD2. So now we have a chance to set the arguments here, which will be the path to the WASM that we want to run. What was that? I think I deleted it. Oh, I had a stupid idea. Okay, hold on. I have to rebuild. Okay. So it was example rs wasm. Pass that as our command line arguments. And then I don't think we care about anything else yet. We should just be able to start this process. Here we go. Let's see if it works. Whoa! It ran it.
Ooh, nice.
All right. See, that was worth it. Feels good to... Yeah.
Congrats.
Registers a WASI type. We allocate a process, set its command line, and then start it, and it runs. All
Only
right.
took 4 extra minutes.
Still a bunch of stuff to do, which I'll probably keep working on today. And probably get a big update on Monday.
Cool. Did you want to do co-working hours this week? Do you want to?
Oh yeah.
Plug that.
Oh, co-working tomorrow. So if you join our Discord,
I'll post a link.
Yeah, we'll do some co-working tomorrow. That's not a Twitch thing. We're gonna try Gather, and it's kind of a regular thing. We're trying to, I missed last week, but every Thursday. Kind of a hangout, just trying to figure out how you can do co-working online in a pleasing way. So we're gonna try Gather, and yeah, that's tomorrow at 4 p.m. Pacific. But I think we'll
2
share
p.m. Well,
2
right?
p.m. Yeah, you're right.
Yeah.
I keep
2 to
forgetting.
4.
I keep thinking it's 4. It ends at 4. And then what else? Yeah, the Gather link we'll post in the Discord. So, do you share the Discord link?
I did in the chat.
I didn't see it. Did it not show up for me?
I'll post it again.
yeah, I guess.
What if I just send a regular message? Do you see that?
A regular message.
Well, I mean, in the chat, like not a link. I see yours. You don't see.
mine.
Yeah.
I don't see yours.
Well. Okay. Well, just in case, I'll send you the link, and
That's
then
good,
you can post.
because
it.
I can't actually generate the link while OBS is running because streamer mode makes the link not work. So this is kind of the only way to do it. Okay, copy. That's weird. Your
Really?
chat's not showing up for me. I mean, maybe somebody in chat can say whether they saw her post, but yeah, that's weird.
Yeah.
Okay.
I'm here.
Anyway.
I promise. Anyway. I'll eat some lunch.
So that's tomorrow, and then did you want to try working on TerraGen Thursday? Is that when you said?
Tomorrow, if you want.
Okay, tomorrow at 11.
Sure.
Finally, TerraGen.
Mm-hmm.
Okay, so we've got more stuff.
Mm-hmm.
All right.
Okay.
See everybody later.
Well, goodbye.
Bye.